14.3 partial derivatives. Let's suppose we have a function of xy, x to the fifth plus y to the fifth plus 10x. This subscript x means partial derivative with respect to x, which we can use this. This funny looking 2 without a tail means the same thing. That's Leibniz notation. But what it means is we treat x as a variable, but y as a constant. And so we differentiate x to the fifth and get 5x to the fourth. Y is a constant. The derivative of a constant is 0. And then the derivative of 10x, the partial derivative, is 10. The y partial, it turns out, well, x is constant. That gives us 0. Of course, you can leave that out of your answer. Take a derivative of y to the fifth. We get 5y to the fourth. And then 10x gives us 0. So let's look at another example. Let's suppose we have f of x y equals x to the fifth, y to the fourth, plus e to the 2x, plus e to the 3y. And let's suppose we want partial of f with respect to x. A little trickier here because we have this mixed polynomial. Well, we're going to treat y to the fourth as a constant. We'll just differentiate x to the fifth, carry that constant along. We get 5x to the fourth times y to the fourth. Derivative of e to the 2x is 2e to the 2x, and then e to the 3y is a constant. So that pretty much just goes away. Partial of f with respect to y, we'll keep this x to the fifth, that's a constant coefficient, and differentiate y to the fourth, 4y to the third, plus, that gives us a 0, and e to the 3y gives us 3e to the 3y. Okay. Now we can continue if we do f sub x, x, that's the second x partial. We do this one first, this one second. You read left to right with the subscript notation. So we need to do an x partial of this derivative. So we're going to differentiate x to the fourth, get 4x to the third. Well, you can differentiate this. It gives you 20x to the third, y to the fourth, plus an x partial of this is 4e to the 2x. Then we can do f sub y, y, and do a y partial of this. So you could pull that 4 out or just leave it here. This x to the fifth carries along for the ride, and then we're going to differentiate this factor here. It gives us 12y to the second, plus this gives us 9e to the 3y. That's a y there. Okay, we have a mixed partial, f sub x, y. And that means we do this first, this one second. So we really want to go back to here. And we want to do a y partial of this. So we do the x partial and then the y partial of the x partial. So you have to keep that in mind. This 5 y to the fourth. Partial of y to the fourth is 4y to the third, plus, now a y partial, that's a constant term, so we just get 0. Of course, you can simplify this to 20, or that's x to the fourth, sorry about that. X to the fourth. You can simplify this to 20x to the fourth, y to the third, but that's just simple algebra. One more example. Let's consider f of x, y equals x to the fifth, y to the sixth. And suppose we figure out the x partial, and that gives us 5y to the fourth, or x. I keep mixing up x and y, sorry about that. Y to the sixth. And then suppose we do f sub x, y. And so we're going to do a y partial of this derivative right here. So we get 5x to the fourth, and then we do a partial of y to the sixth and get 6y to the fifth. Of course, we can simplify that to 30 x to the fourth, y to the fifth. Now let's reverse this. Let's do y first and then x. So we'll do a y partial up here, and we get x to the fifth times 6y to the fifth. And then let's do f sub yx. So we'll do an x partial of this. It gives us 5x to the fourth times 6y to the fifth. And of course, we can simplify that to 30x to the fourth, y to the fifth. And it should be no surprise, these two are the same thing. If you look at this polynomial function, you can do 5x to the fourth, 6y to the fifth, or you can do 6y to the fifth, 5x to the fourth, same thing. Matter of fact, if these first partial derivatives exist and are continuous, this applies to any function. It can be a sine, a cosine, or an exponential function, a logarithm, what have you. The order does not matter. The different order defines a different process, but the answer always comes out the same. So that's all for this video. We'll be back with another video or two shortly.